introduce algebra being x, y's, variables, a's, and b's, probably should review some arithmetic with your students, some, just for good measure, because it's the foundation for how you deal with a's and b's and x's and y's. For instance, you need to remind them that anything divided by 0 is undefined. Those principles. And why? If I have 3 cookies and I'm going to divide them by 3, well, that's one group. If I divide them by 1, that's 3 groups. But if I divide them by 0 and take out 0 groups, take out 0 groups, take out 0 groups, I still have 3 cookies sitting here. And I can't do it. I just can't get them all out. So, there's a really good reason that dividing by 0 is nonsense. It's not defined because it can't happen. Also, the absolute value of something. Of course, the easy way that they kind of remember is what to do to it. What do you do to the -4? You make it positive. But you should remind them of a couple of other things that will help them in their future. One is that it's defined as a distance from 0 on the number line. So it's 4 units from 0. This -4 is 4 units from 0. Also, when they get into statistics, this definition comes up when they're looking at finding distances actually, because they'll square something and then take a square root. They won't need that for a while, but when they get into standard deviations, that's another way that sometimes the absolute value of something is represented. And also, if you were to have a discussion about piecewise functions, this is a really good opportunity to do that. Because piecewise functions, they look scary at first to students, but they're really not that big of a deal. They're if-then statements. So when you have the absolute value of a number, there are 2 possibilities. Either you could keep it the same. When would you do that? If the number itself is already 0 or larger, then you would keep it the same. However, if it's a negative, then you actually take the opposite of it. So the opposite of x, if x is less than 0. Now this is probably not something you want to do in the review, because you're introducing variables. Maybe you do want to do it in a review, but you're introducing variables and inequalities. So, I'm assuming that you kind of know a few things here. But this is a really good way to tie in piecewise functions and what a piecewise function looks like when you are ready to introduce piecewise functions and that structure and inequalities. So even though finding the absolute value of a value seems really easy to the students, these other representations do come up later for them. So it's nice to know more of the embedded meaning of absolute value. And also it's good to remind them how to add fractions and multiply fractions and divide by fractions. Just do a little short recap of that, because it's also going to inform how they work with rational expressions in algebra. That they can't add 2/3 and 1/7 until you find a common denominator. You multiply this fraction by 7/7, then you get 14/21. You multiply this fraction by 3/3, then you get 3/21. Then you can add those, and the denominator is like a unit. You're saying 14 of something plus 3 of something is 17 of something. And so the bottom is a unit. This is so similar to how just in a few lessons later, you're going to want them to add 14x plus 3x is 17x. And you're going to emphasize that concept of a unit but the x is a unit. Well, they've been doing this with fractions. That's why I'm emphasizing that tiedness in, just to let you know that you build on that prior knowledge and say, this was a unit fraction. How many 21sts was it that you had here? How many 21sts was it that you had here? And that you have to have a common denominator, similar to how a variable is going to have to be a common variable in order to combine like terms, not unlike terms. So there are a lot of similarities there. Another good reason just to remind them of fractions and how to deal with them. So part of speaking the language of algebra is having some basic properties understood and when they apply, when those basic properties apply. In my opinion, the most important ones to emphasize in vocabulary are these three. There are some other properties that are kind of self-explanatory, like the zero product property is about zero and about products. So some of them are more intuitive by the name of it, and they can almost like pick it out of a lineup because of what it's named. But these three, I feel like, are less intuitive, and students have more problems identifying which one is which, and they are very important. Associative property only holds with multiplication and with addition. With multiplication, the associative property looks like this. You might have A times B in parentheses times C, and it's going to be equal to A times B times C, and the parentheses are the only parts that have moved. That's what I emphasize to my students is notice both of the sides say ABC, ABC. The elements, the terms, or the factors themselves in this case, have not changed order. ABC, ABC. It's still in alphabetical order, or whatever order it started with. The only thing that has moved have been the parentheses. So if I can get them to associate the word associative with parentheses, then that's usually helpful. Sometimes I would draw a picture using parentheses or something, or draw the word using parentheses, something that might help them remember. With adding, it would be also similar, except this time you have plus signs. So on one side, I might have A plus B plus C with parentheses around the first two terms. But then over here, I might have A plus B plus C and parentheses around the second two terms. So the only thing that has moved has been the parentheses. And notice that when I'm saying this, the language that I used with the first line was factors. A, B, and C were factors because they were being multiplied together to get a product. However, in the second line, the words that I'm using were terms. Terms are being added to get a sum. So you could, that's usually also in the introduction to algebra portion to make sure you get a handle on using the right language. Then the commutative property also holds with both multiplication and with addition. The commutative property, that's the one where the terms or factors actually switch. So for instance, x times y equals y times x with multiplication, and then with addition, maybe a plus b equals b plus a. These are things that we have known to be true for a while. You were probably fairly young when you first learned that you could switch 2 plus 3 and 3 plus 2. The distributive property is kind of a blend between multiplication and addition, but a very specific blend. Notice if you had something like 2 times the parentheses and then x plus y inside the parentheses, so 2 times the quantity x plus y, people usually draw arrows and they say, I'm distributing the 2. That's true. And you distribute it through multiplication. You multiply the 2 times the x and multiply the 2 times the y. I remember one time a student asked me, why does the distributive property work? And I was so happy about that question. Why does the distributive property work? I got to thinking, this is a weird question. It's just something that we learn at such an early age that we often don't question it. So it took me a moment to think it through, and then I said, well, if you had 2 times x plus y, and x plus y being unknowns, I'll just represent them as sort of this distance and this distance. Well, that would be the area of this entire thing, because it's length times width, right? This entire thing is x plus y. Well, what's the area of this box? 2 times x. What's the area of this box? 2 times y. So it's just a different way of representing the same area. It's to say 2 times x plus y. So there's a quick area definition or a representation. You have multiple representations to show them a picture of like why something is what it is, why something works. Same thing with the commutative property. If you say why is length times width the same thing as width times length, you say just turn the rectangle. So some of these are even more intuitive. But the distributive property, if someone asks why does that hold, why does that make sense, draw a little picture of it. You could use counters in a more of a discrete model rather than a continuous model. And you could say I have, let's say 2 times 3 plus 4. Well, 3 plus 4 is 7. And then if I had 2 of those, okay, there's 1, and then the second one, the second group could go here. Well, here's 2 times 3 plus 4, one way to represent it. But then if I wanted to split that up into this group and that group separately, I would have 2 times 3 and 2 times 4. So it's like a different, slightly different organization of the same number of items. So you can have a discrete model or a continuous model to show that.